We're going to look at the D3-Brush function. And what brush does is it allows you to zoom in on a particular part of your chart, just like we did there, so that you see that we've zoomed in on our data. And if you want to zoom back out, there's a reset zoom here, and out you come again. There's a D3 zoom function itself, but D3-Brush I find easier to operate and easier to understand. So I'm sticking with D3-Brush. The code is complex, so we're as well to get into it. So here we are in my GitHub page, abemonley/D3 tutorial, and we're going to go to the most developed of the simple iris scatter plots, which is creating axes in D3. So that's as well as the scatter plot, we've got axes with it, and that's what we want. We just copy this, copy raw file, go over to our editor, and just paste it in and save it. Then we launch a terminal, see if it works. Hell's bells, excuse me. It's Python 3 I haven't recently updated Python. I forget that it's Python 3 now instead of just Python. Anyway, so here is the iris chart as we know and love it, and we're going to go through the code now and see what we can keep and what's going to hit the bin. The dimensions are fine, the headline is fine, plot height is fine, canvas plot is fine. The scales we're going to change a little momentarily. Now we're just going to comment out vids, because we're not going to delete it because we're going to use it later, but we're going to comment it out because as we're going back and forth it'll throw an error. I don't need that. So the same with the call to tooltip. We're going to have to make some changes to the axes as well, but that's fine. We'll jump each of those hurdles as we go. So the first thing to do now is look at a clip path. So what's a clip path? The documentation says that a clipping path restricts the region to which paint can be applied. Conceptually, parts of the drawing that lie outside the region bound by the clipping path are not drawn. So I've no idea what that means. All I can tell you is this is the code that works, and therefore I'm going to use it. You know, if you're making a recipe, right, you're going to make a banana bread, and to throw in bananas. Best not to worry about what a banana is metaphysically. Thing says throw in bananas, throw in the bananas. So that's how I'm considering this clipping path. I don't understand it. I'm just copying the code from the documentation, and it works. And as long as it works, it stays in the show. So we're creating our clip path here just below plot. Very straightforward code. We append the clip path, and we give it a width and a height, which are the same as plot width and plot height. Now we create a second object as well, which is called view, and it's on this view, which is view and clip path go together, right? There's no point having a clip path if you don't have a view. You can't have a view without a clip path, insofar as I understand the documentation, which, as I say, mightn't be very far, but trust me, this works. This works. So the attribute has a class view, and there's also a clip path attribute which takes URL hash plot. Hash plot because we've given the clip path an ID of plot. Hash is for ID, and plot then is the name of that particular ID. So having saved that, we're going to launch the Fox and take a look to see if anything's broken. That's the official documentation that I read the quote from. We'll take a look at the console here. Just blow it up a little so you can see it. Go into the inspector, and we see the canvas that we've seen before, the SVG that we've seen before, the G that we've seen before, and here's our view. And then there are the axes and the axes labels. and down here is our defs object with the clip path. Okay, that all looks great. We'll just shut down the terminal, and we're going to start working on the scales. Little difference that we have to, or little change that we need to make here, is that we need to create a separate domain object, because the domain is going to change as the brush works. Therefore, we need something to store the original domain selections, or the original domain measurements, values, whatever you want to call them. So instead of chaining domain as part of a chain here, we're going to chain each domain, each X and Y domain, to their appropriate objects. So we're going to write xScale dot domain, and then the parameter, which obviously we've just copied, right? We've cut out of where it was, and we're just calling it a little later in the code. Nothing else changes. We're only calling it later in the code. Other than that, it's exactly the same as it was. And we're calling it later in the code because we want to create this domain object, which we're going to use as part of the brush functionality. If we want to reset a brush, we can't reset it without knowing what the original domain was, because the domain will change as the brush works. This will all become clear in time. Okay, so we set the X and Y keys to X scale domain and Y scale domain of our domain object. And that's great. Now we come to work on the axes. Where we called the axes here before, we're just going to change the nomenclature here a little, because we're going to put in a grid. And before this, we've just had the axes. Now we're going to have grid lines as well as the axes, just to, you know, when you zoom in on a scatter plot, if there aren't grid lines, it starts to look a little bare. Therefore, we're going to add the grid lines. And just for clarity, instead of calling these x-axis and y-axis, we're going to call them x-axis holder and y-axis holder, because it'll be more consistent with the grid lines that we're going to create in a few seconds, less than a minute. And instead of calling as the final element of the chain, we're going to call the axes separately. So it's x-axis holder call x-axis, y-axis holder call y-axis. Now, having created x-axis holder and y-axis holder, we're now going to create x-grid holder and y-grid holder, and this is going to hold the grids. So they're quite easy objects to create. They're just another G. G stands for group, that layer on top of the visualization. The grids themselves are functions. So we have xGrid here, which takes parameter G. And onto G we append a class of grid line. And now we have four attributes. We select all, which would be a line. Our data is xticks. The xticks method of xScale, and that way our grid lines match the ticks, so that you don't have grid lines coming from nowhere and ticks that don't match up. So after data we call join line And now we have 4 attributes, which are x and y1, sorry, x1 and y1, x2 and y2 for the lines. So x1 and y1 will take D maps to x scale D, because these are locating the ticks. Y1 is going to be 0, because obviously the tick starts at 0. And then it'll end at plot height, because you're drawing from the bottom to the top all the way. So these are constant values. And then for the Y grid, you essentially reverse that. So this is Y grid. It'll still be lines, obviously, but we are using the Y scale ticks instead of the X scale ticks. And the constant values this time will be the X's. So it'll be 0 and plot width. Because it's starting at 0 and goes all the way across to plot width. And then the tick values will be D maps to Y scale D. So now we're going to call X grid holder and call X grid on it, and the same for Y grid holder. And then we launch the Fox and hope that it's looking okay. So we launch our terminal, which doesn't say, here it goes. Launch the server, go over to the Fox, get a look at this thing. And we don't see our lines, which is disappointing. Click inspect, and we'll see if there's anything there. So something can be drawn and us not to see it, and that's what's happened here. We see that there is a grid line class, and we see recognizable grid lines with recognizable numbers. So the lines are there, we can't see them. Why can't we see them? We can't see them because we haven't styled them in our CSS file, but we shall style them now, and that'll solve our problem. So you might remember we gave these grid lines a class of grid line. So we'll put in 2 values here. We're going to put in a stroke width of 0.5 pixels because we want this to be very thin, and we'll put in a stroke of grey because, again, you know, your grid lines have to be subtle. So we'll save that, relaunch the Fox once I find it. Here it is. And here are our grid lines, large as life. So that looks fantastic. The next thing to do now is to create our brush. So to create a D3 brush, the code is quite simple. Constant brush equals D3 brush, and then you tell it what to do in the case of an event. It can respond to 3 events. The events are start, move, and end. The only event we're interested in is end, which is what happens when you let go of the brush. So you drag it across something and then you let go, what happens. And we're going to write a function called detail, which details what happens when you let go of the brush. Detail takes 1 parameter, E, which stands for event. We're going to put in a console log, 2 console log statements actually. The first one says I am detail, so that you can tell what's happening with this thing. And we want it to respond if it receives an e.selection object. And we just put in, we just note that these are the ends of the 2 of the if statement and the function, because it can get confusing otherwise. We're going to log the e-selection event just so we can take a look at it, because it's a little, you know, it's not obvious what it is, and it might become less obvious as the code goes on. We're now going to create 4 constants, or 4, we're now going to fill, I should say, 4 parameters for variables with that e-selection event. It's going to be min x, min y, max x, max y. and we're going to use those 4 parameters to create a new domain according to where the brush has zoomed. So we have 4 points of the brush: min x, max x, min y, max y, and we're going to use those to create new domains. We're going to create the domains by calling invert on x scale and y scale. So our first new domain is new domain x, which is equal to x scale invert min x, x scale invert max x, and the new domain y will be the same thing with just the y substituted for x. So once that's done, we're now going to associate these new domains with the domains of the scale, which means that we're going to call x scale domain new domain x and y scale domain new domain y. So all that done, we call the update view function, which we're going to be writing shortly. And we just have 2 more things to write here. One is that to turn off the brush, essentially, and the other thing is to make the reset zoom button visible. We leave it invisible by default, and we make it visible by setting the opacity at 1. Now I'll just write the update view function here, because I'm going to launch the server, launch terminal, launch the server, launch the Fox, and see if anything is happening. Here's our grid. We launch the console, and we're hoping to see IM detail when I create a brush here, and nothing has happened. Okay, I know why that is. It's because I haven't attached the brush to the view. That's fine. I'm going to be doing that momentarily, but the first thing I'm going to do is I'm going to create the update view function. Update view is going to do 3 things. It's going to redraw the axes, it's going to redraw the grid lines, and it's going to redraw whatever circles are captured by the brush and the rectangle that the brush draws. I'll also put in a console log just to make sure that it's working, because you know, when you're learning this stuff, that's what you like to know. You like to know which function is firing and which isn't. So this is simple enough code. X-axis holder call X-axis, X-grid holder call X-grid, and the same for the Y's. And then we do what is essentially the top slice of the scatter plot that we've been doing before. View select all circle and give them a center X, center Y values. Or attributes, I should say. Okay, we need to create another function, which is what happens when someone hits the reset zoom button. So the first thing we're going to ask the reset button to do once it's been hit is to disappear. And we make it disappear by setting its opacity to 0. Then we restore the original domains to the X and Y scales. You might remember how earlier we made a point of creating a domain object so we could store them. This is why we did it. The domain object that we created up here, this is where it comes into use. So when you hit the restore zoom, the reset zoom button, what you're saying is please restore the original domain to the X and Y scales so that we'll go back to where we came in. And we have to update the view once those are done. So the view has to be updated if the brush operates or if the reset zoom button is hit. It's easy enough. Create a button, like a button tag, give it an ID of reset zoom or zoom reset. Give it a text of reset zoom. Bob's your uncle. Okay, the third last thing we're going to do is write a scatter function. But we don't really have to write it because we already have the two parts of it already existing. The code for the scatter function is the same as the code that we used to create a scatter function in the 6th lesson or whatever it was. So we just uncomment it, cut it, and paste it in. And we're going to, as well as that, we're going to make two calls, which will be how to respond and mouse over and mouse out to make the tooltips work. So again, we have that code already existing. We copy it, cut it, and paste it in. Oops, hit the wrong button. Control / is the correct button. And with that done, there's only two things left to do. One is to call brush on our view object. We hadn't called brush in the view object when we tried to look at it the last time we were in the Fox. That's why nothing happened. But we're going to do it right now. And we also have to call scatter so that our scatter plot appears in its basic shape. Okay, let's have a look. And here it is, looking as it should. We'll try the brush. There's our versicolor. Throw a brush here at that intersection. See what it's like. Okay, and this is the zoomed in version of that. You see that the distances have become smaller in the axes. That's one of the joys of the axes. We hit reset zoom there, the zoom button has disappeared. So we'll just go back at the code now, or actually we'll take a look at the console to see the console reminders that we saw. This is the select, the event selection data, and you see the 4 values that we had here that we used to create min x, min y, max x, max y from that selection object. So we'll just tidy up this code, get rid of the hanging comments like that. There might be another one down here. Just a little space you could format. JavaScript, for all its sins, you can right click and hit format. and that works out okay. Close the terminal. I'll reopen the terminal, launch the Fox again, and there's our lovely graphic. And that's it. That's how to use a D3 brush. So this is the last in this series of D3 tutorials. I haven't shown you everything that can be done. There's still other things that can be done. But I will say in my own defense, I think I showed a hell of a lot. About 9 hours of content here. So I hope it does someone some good. I found this very, and I still find it very hard to do. And I hope this is of some use to a brother from another mother, as it were, or a sister from another mister. That's it. I'll be back with something else soon. Take it easy. Peace and long life. Live long and prosper.